Hello, EPICS 1 students, and welcome to our program. This is Leslie Light, Director of EPICS, speaking, and I'd like to introduce the program and a couple of our initial deliverables. With me is Sue Anderson.
Hi folks, I'm a creative problem-solving expert and designer of medical devices. This will come in handy, as you'll soon learn when you see our client's letter.
I thought it fair to warn you up front that EPICS is not a normal technical class. For sure, some of the time in class will be spent in more typical lecture style, but often you'll find yourselves working in your teams and applying the concepts learned in class. Let's take a look at the course's learning outcomes. Our first outcome is to apply creative and critical thinking skills through a guided design methodology with an emphasis on visual solutions. More soon on our creative problem-solving process. But I'll mention that talking and writing are two ways to communicate ideas, and that we'll show you that graphics and prototypes will help you get your ideas across even better and faster. Our second course outcome is to analyze alternatives to select the most desirable option. You'll learn how best to generate ideas, and then how to select among them for the best concepts to develop with your team. Third learning outcome is to participate on a team to solve an open-ended problem. Ah yes, this is one of those things EPICS is famous for. Suffice it to say that this won't be your last team experience in your career, nor your last open-ended problem to solve. The last learning outcome is to learn and use communication skills, both outgoing skills like technical writing, graphical representation, and oral presentation, as well as incoming skills like interviewing, observing, listening, and user empathy skills. And in case you were wondering, that is an 11-year-old boy this team is presenting to. Why? Because they're designing a STEM toy and they're collecting user feedback. So here are some aspects of EPICS that will make your experience with us different than in your other classes. One, we're going for hands-on learning. We'll teach you a skill and then work with you to apply it. This is true for making prototypes, identifying and interviewing stakeholders, presenting. You get the idea. 2, the course has a strong focus on communication skills. You'll have a lot of practice communicating, again, both the outward skills like writing, presenting, and the incoming skills like listening, interviewing, and observing. You'll soon find that both are critical to being a good problem solver. 3, we're dealing with a problem that is not perfectly constrained. In your calculus class or in your statics class, you're asked to solve problems that have one correct answer. And your problem statement will include all the information that you need to solve that problem. While it's critical to learn these skills, it is also critical to learn how to solve problems that either have too few or too many constraints, as you will certainly encounter these kind of problems in the real world. Anyway, our challenge to you is this. Don't let these aspects frustrate you. Enjoy them, learn from them, and be that much more confident as you head out to solve the problems of the world.
This is Sue again, and I'm going to introduce the creative problem-solving process. This process is used for solving complex open-ended problems. In other words, ones that have either too few or too many constraints, like your EPICS 1 project, and like many problems you'll encounter in your career, whatever that may be. This is a diagram of the creative problem-solving process that you'll use to create solutions to your EPICS 1 project. As you can see, the process has 4 basic steps: problem definition, exploration, analysis, and implementation. Here's what those steps look like in the context of EPICS 1. In the problem definition stage of the process, you'll do some research in order to understand the problem, the constraints on the problem, and the client's requirements for a solution to the problem. You'll also define the users or stakeholders who will be affected by your solution to the problem. And you'll try to anticipate the needs of those users within the context of the problem. If necessary, if the problem is over-constrained or under-constrained, you'll redefine the problem in a way that maximizes your chances of coming up with a great solution. In the exploration stage, you'll do more research on background information that you may need in order to solve the problem. You'll also interact with the users in order to understand what their needs are in this context. And you'll develop empathy for the users that will allow you to look at the problem from their point of view. This step also involves generating ideas for potential solutions to the problem using brainstorming and other idea generation tools. You'll then take those ideas for potential solutions and further develop them into solution concepts that will meet the user's needs. In the analysis stage, You'll apply the user needs feedback that you gathered in the previous step in order to evaluate each of your potential solutions. Using your problem definition from the first step of the process, you'll generate criteria for a successful problem solution and use those criteria with decision analysis tools in order to choose the best of your potential problem solutions. You'll also generate a cost analysis to use as one more criterion for selecting the potential problem solution that will best meet the user's needs. In the implementation stage, you'll take your best problem solution and add details to develop it further. You'll build prototypes, generate graphics, and write a final report in order to communicate your final solution to the client and receive further feedback about your solution. Each of these 4 steps offers you opportunities to test your potential solutions and refine them based on user feedback, incorporating that feedback to improve the quality of your solution. This test, refine, iterate cycle is what turns a good solution into a great one. Remember, this process is applicable to all sorts of problems. You use it in EPICS, maybe in senior design, and in diverse workplace problems in science, engineering, and many other fields. Don't underestimate the power of this seemingly simple process. This process, or some variation of it, is how companies like IDEO, Apple, and Google produce world-class innovation.
So now let's cover your class assignments. Your mentors may have already posted the course syllabus on Blackboard, which includes this list of your deliverables. We're going to explain 2 of them now. Here's Sue to explain the design log.
Your design log. Here's what it is. It's a repository of all of your thinking about your EPICS 1 project, including graphics. For your design log, you'll need to get a bound book with blank pages, and these are available at the bookstore. A standard spiral notebook with lined pages will not do. In this blank book, you'll record a bunch of things related to your project. You'll record your research, your interviews, your observations, your personal experiences, and your bug lists, all as related to your project. Now, a bug list in this context is not the kind you may be familiar with from computer science. It's a list of problems and opportunities for improvement related to your project. Your bug list should come from user feedback as well as your own observations and experiences regarding the project topic. Your design log should not just be written notes. It should include quick sketches of the concepts that you come up with. Reason for this is that quick sketching will give you practice in conceptualizing and visualizing, which are critical to turning ideas into problem solutions. Now, if you're feeling a little nervous about these sketches, your graphics classes covering quick visualization will give you the skills to do these quick sketches, so don't worry about that. Your design log doesn't have to be neat or pretty or perfect. It's a working document for you to help you in the creative problem-solving process. Your design log is a semester-long assignment starting in this very class or as soon as you get your blank book. Think of it as an opportunity to show your instructor how great you are at the problem-solving process that I just talked about.
The second deliverable we'll introduce now is the clarification email, which will help kick off your problem-solving process. The purpose of this assignment is for you to show your mentors that you have read the client's letter and other accompanying material, and that you understand the requirements and the needs of the client. It's an opportunity for you to think critically about what information from the client you have and what information may be missing, and for you to ask further questions. It should be a formally written document addressed to your class mentors, who in our course represent your managers. It will be due the 3rd week of class, and it's an individual assignment worth 5% of your grade. Your mentor will provide specifics on the exact due date and how they wish you to submit the assignment. And now we'll hand it back over to your mentors. We're really excited about the semester and the project, which we'll introduce to you shortly. Good luck with the start of your semester.